right? Now in this particular discussion, we'll be studying about search operation. That means procedure to find an element from the existing linked list. We're trying to find an element from the existing linked list. The search operation to find an element from the existing linked list. Now, what is the procedure? First, we have to traverse the entire linked list sequentially. That is, starting from the first node, you have to go up to the last node and compare the data part of that. Compare the data part of the node which we are searching, the key node, along with the element present in the linked list. If the search matches for any of the nodes, search is successful. And once the search is successful, what we do, if it is successful, return the location of the searched node as soon as the match is found. After comparison, that is linear search, very similar to linear search. You go on comparing one element at a time. If the search is successful, just return the location of that particular element. Now, if after matching each and every element, if the search is not successful, it is possible that the given element is not present in the linked list. The given element is not present in the linked list. Right? So how can we traverse? By using the next pointer or pointer field of the node, because we know every node has two parts in the linked list, the data part and the pointer part or the next pointer part. So next pointer part is always helping us to point to the next node, always helping us to point to the next node, right? So let us see an algorithm to search a specific element in the linked list, a specific element in the linked list. So for that, we need to assume one linked list. Node 1, node 2, let us take 4 nodes, 10, 20, 30, 40. Perform the linking between the two nodes, because next pointer of every node is pointing to the next node of the linked list. It is null because there is no next node. And we know the special two pointers. What are the special two pointers? I think now it is, now we are used to the notations. I'll just write F for the first pointer and L for the last pointer. First F is pointing to first node of the linked list and L is pointing to last node of the linked list. Say assume for traversal purpose, I'll take this node to be deleted because we can iterate through the algorithm 2 times. So that means I want to search for an element called 30 in the linked list. We want to search element called 30 in the linked list. So we'll start the algorithm, or we'll look at the procedure for searching it. What was the logic? We will just keep key in a variable called key, or hold the value which you want to search in some node, and that is 20 in our case. The node which we want to search is not 20, I said 30. So we want to search an element called 30 and see whether that element 30 is present in the linked list or not. Present in the linked list or not. Now, it is possible that the linked list can be empty. You want to search for an element, but there are no elements in the linked list. In that case, what we do, we say that search is unsuccessful because the linked list itself is empty. So that's what we are doing in this step. What is that? If first is equal to null, if this F is pointing to null, what it indicates? It is pointing to the nodes which are not existing. In that case, we'll go to step 3. What step 3 says? Just search is unsuccessful. The given element is not present. You want to find, but there are no nodes in the linked list and the given node is not found. Else go to step 4. So else part, what we do, we go to step 4 and now we use a pointer called PTR for traversal purpose. What it indicates, if this case is failure, what it indicates, at least there is one node in the linked list. That indicates that at least there is minimum one node is present in the linked list and we can perform our search operation. So what this line does, set PTR equal to first. That means take a pointer called PTR, take a pointer called PTR and make it to point to the very first node of the linked list. Take a pointer called PTR and make it to point to very first node of the linked list, because you have to traverse from first node and go up to the last node and perform the comparison. Go up to the last node and perform the comparison. So it is specifically as per our notation, instead of taking this as key, it will be better if I write it as value, because that is the value which we are searching. Value or key, whatever variable name you use in programming, that is acceptable. Whichever variable name you want, you can use, right? So PTR. Okay. We have used a PTR for traversal purpose and for the comparison purpose, for traversal as well as comparison purpose. Now what's next step says, we have to repeatedly perform steps 6 to 8. That means these three steps you have to repeatedly perform 6 to 8 until we encounter the last node. Till we reach the last node, you have to repeatedly perform the steps. Now what these steps involve? These steps are nothing but comparison of the data. These steps are nothing but comparison of the data which we are trying to find. So let us see first step number 6. What we do in this step number 6? As the logic says, you have to compare this 30 with data part of the PTR. Compare this value 30 with data part of the PTR. So that's what we are doing. What is that? If check is the PTR pointer information, is it equal to value which you are searching? PTR pointer info, because we know every node contains two fields, information field and next field. Information field and next field. Information field and next field. Information and next. Right? So what is the logic? Check whether PTR pointer info, that is 10. That is, we are checking every time. 1 second. What we are checking? If statement. If PTR pointer info, is it equal to, what is that, value? This is what you have to check every time till you encounter the last node. Because after comparing even the last node, if you are not finding the value, then we say that search is not successful. Then we say that search is not successful. Now let us first check. What is PTR pointer information? PTR pointer information is what? PTR pointer information is 10. Is it equal to value? What is value? Value is 30. Are they matching? No. The condition is failing. In that case, what we do, if this is equal, then only we go to step number 7 and say that search is successful. Now in this case, comparison has failed and we have to go to step number 8. What you have to do? If this node is not matching, check whether the next node is matching. So that's what we are doing here. Make the PTR to point to the next node, or PTR pointer next is assigned to PTR. In other words, make the pointer, advance the pointer, increment the pointer and make it to point to the next node. That is PTR equal to PTR pointer next. After this step 8, what is the impact on the background? So what happens here is this PTR is being incremented and made to point to the next node of the linked list. So PTR. Now PTR is pointing to the next node of the linked list. As you can see, what it says, we have to repeatedly perform these steps 6 and 8. That means now again go back to step number 6. You have to again go back to step number 6 and perform the comparison. Go back to step number 6 and perform the comparison. Right? So again, check whether the information field of the PTR, is it equal to value? Check this line. You check whether the information field of the PTR, is it equal to value? What is value? What is PTR pointer information? PTR pointer information is 20. Is it equal to value? What is the value you are searching? 30. Is it, are they equal? No, they are not equal. So if they are not equal, what we do? We go to step number 8. What happens in the step number 8? Again, increment this pointer, make it to point to the next node. Until when we have to repeat this? Till we encounter the last node. till we encounter the last node, we have to repeat this. So as per this step, what happens? Now PTR is being advanced to point to the next node. I'll erase this and I'll make PTR to point to the next node in the linked list, because we are simply doing linear search by comparing element. Now let us go back to again step number 6. We have to go back to again step number 6. Okay, what is happening in step number 6? Now compare the information field of this node. Is it equal to the value which we are searching? That is PTR pointer info, is it equal to value? What is PTR pointer info? PTR pointer info is 30. This is 30. Is it equal to value which we are searching? That is also 30. Now this is the match which we have found for the first time. Then what we have to do? We have to go to step number 7. What step number 7 says? Return, that is just display a message saying that search is successful. The element which we are looking for is present. The element which we are looking for is present in the linked list and the search is successful, and we will stop. We will stop here. We'll stop here. Now assume that after the entire traversal, if the element is not present, that also we have to check. The failure part also we have to see what the failure part says. If it is possible after comparison of all, the last node could be left out. That is, always the PTR is pointing to the node previous to the last node. So look at the logic here. We will go to the previous next node, and when PTR is present here, now that was the case when we have searched value 30. That was the part which was successful. Now let us just slightly change the procedure. That was successful and we have stopped it. Assume we have iterated the entire algorithm once again, and the value which we are searching is 40 now. That means 40 is last node, so that I can explain this other part also. The value which we are searching is 40, and that is nothing but the last node in our linked list. Last node in our linked list. That's what we are checking. It is possible. That is, the last node can be the node which we are searching. The last node can be the node which we are searching. So that's why we check whether the information field of the last node is it equal to value. In this case, it is successful. Then what we do? We go to step 10. We go to step 10 and say that search is successful and stop. Else, even after traversing all the nodes from 1 to n minus 1 and the last node, nth node, all the nodes we have compared, but the element is not found. That is the last step. What we do in the last step? Search is unsuccessful. What we have done? We have searched all the elements in the linked list, starting from the first node and up to the last node. After comparing all the elements, we were not able to find the element, and we display a message saying that search is unsuccessful. Search is unsuccessful. So that was the simple procedure for searching an element in the linked list. Okay, that was an procedure for searching an element in the linked list. So are we connected till now? Is there any issues? Are there any difficulties? Can someone respond? Is there any network problem, synchronization issues? Things are okay, right?
Yes, sir.
Okay.
Yes, sir.
Okay, now let us see the display procedure, displaying all the elements of a linked list. So let us assume that we want to display or print. We want to display all the elements present in a linked list. For display, we need to assume an linked list first. So that linked list, okay, I'll show it here. We have the space. Assume that we have this linked list and we want to display those elements or print those elements 10, 20, 30 and 40. are the nodes. This is pointing to null and these are the pointers. Pointers which are pointing to the next node. And what are the other two special pointers? First is always pointing to the first node of the linked list and last is always pointing to the last node of the linked list. So this is the fact which is known to us. Now when we have this particular scenario, we want to display all these numbers. That means when you execute the print function, you should be able to display all the elements in the linked list. It is like you have to traverse the whole linked list in a linear fashion. This is nothing but you have to traverse the whole linked list in a linear fashion, starting from the first node and go up to the last node. That is a very simple procedure approach what we use for displaying elements of a linked list. So again, we have to traverse in this case. So print, it will not take any of the parameters now. Like how we use parameters for create, uh, insert and delete. But here we are not using any parameters because we are simply displaying the nodes present in the linked list. Obviously, the algorithm will start with the first step, that is start. Now, what is that? Whenever you want to print the linked list, it is possible that the linked list is empty. There are no nodes in the linked list. When there are no nodes in the linked list, that condition is satisfied by this particular statement. That is, if first is pointing to null, we know that first node will always point, first pointer will always point to the first node of the linked list. But in our case, if first is null, that indicates there are no nodes in the linked list, and we'll simply skip to step number 3. We'll simply go to step number 3. What is happening in step number 3? We display that linked list is empty. You want to display the elements, but there are no nodes in the linked list, and we display a message saying that linked list is empty and will stop. And we'll stop. Else part. Else part, what it says, we'll go to step number 4. What else indicates? There are some nodes in the linked list. At least there is one node in the linked list. That means, and now you are free to display the elements. So we'll go to step number 4. So when you go to step number 4, it is possible that there are at least one node. And if it is the case that there is only one node in the linked list, it is also possible. There is only one node in the linked list. First is pointing to the same node and last is also pointing to the same node. That is possible. That is what we are checking. If the first and last both are same, that means first is pointing here, assume this case. Last is also pointing here, assume these three nodes are not present. 20, 30, 40 are not present. Only one node is present. First is pointing to 10, last is also pointing to 10. That is the case what you are checking. If that is the case, what we do, we go to step number 5. What we do in the step number 5? In step number 5, we simply display that value. Display first pointer information, that is display 10, and then we'll stop. That means this is the case when there is only one node present in the linked list. Now that is not the case in this. That is not the case. What is the other case here is else part, we will go to step number 6. So what is the step number 6 says? There are more than one nodes now. There are more than one nodes. Now you are required to traverse the linked list. It is possible that there can be 2 nodes, 3 nodes, 10, 20, 50, whatever. It is possible. Now we need a pointer PTR for traversal purpose. Now we need a pointer PTR for traversal purpose from step 6 onwards. From step 6 onwards. That is, take a pointer PTR and make it to point to the first node. That is first equal to PTR. So take a pointer PTR. I'll write it here. PTR. Now we have taken a pointer called PTR and made it to point to the first node, because you have to go on displaying from the first node up to the last node. Now we have to repeat these two steps. What are the two steps? 8 and 9 until you go for the last node. So these two steps you have to repeat. Step number 8 and 9. We have to repeat steps 8 and 9. So what happens? Wherever PTR is pointing, the very first step here is just displays information. I will write the output here. I will write the output here. So what is that? I'll try to display the output here. Just display PTR pointer info. PTR is pointing to this node. What is the info field present in the PTR? PTR pointer info is 10. So 10 I am displaying. Then we have to go to step 9 because these two we have to repeatedly do now. This is the loop what we are using here. Step 8 and step 9. What happens in this, once you display this value, you should go to the next node and display the next node. That is the logic till you go for the last node. And how to take this PTR to the next node? Just to make PTR and make it to point to the next node. That is, execute the statement saying that make PTR to point to the next node. Make PTR to point to PTR pointer next node. Or in other words, address of the next node is assigned to the PTR. Now PTR will not point here, it will point to the next node. Erase this. Where PTR will point? PTR will point to the next node now. PTR has been advanced and now it is pointing to the next node. Now it's pointing to the next node. Again go to step 8 because we have to execute them repeatedly. We have to execute them repeatedly. Go to step 8. What is happening in step 8? Just display the information part of the PTR. What is information part of the PTR? That is just display PTR pointer info. What is information part of PTR? 20. And next we will display 20. Go to step number 9. What is happening in step number 9? Now make this PTR, make it to point to the next node. What I'll do, I'll erase this and I will advance the PTR and make it to point to the next node. That is 30 in our case. Okay. After that, what is step 9? What step 9 says? Step 9 says, no, not step 9. We have done step 9. We have to go back again to step 8. What step 8 says? Display the information part of the PTR or display the information part of the node where PTR is pointing to. So where PTR is pointing? PTR is pointing to this node. What is the information part of that? Information part is 30 and we have to display that. So 30 will get displayed in the output. After that, go to step number 9. What is the logic? Now take this pointer to the next node. Take this pointer to the next node. Now, till what we do this here is, it is possible that we will take this pointer, PTR pointer info up to the, actually there is one little mistake here, what I feel. PTR pointer next, because here there is no condition to check. Here there is no condition. What they have assumed here is, they have assumed here is the PTR will go up to the last but one node. It cannot display the last node. So that's what they have taken one more condition. Once we displayed all the possibilities, what step 10 says? What step 10 says? Display the information field of the last node. We have, if there are 100 nodes in the linked list, we have displayed all the values from 1 to 99, and for the last node, just make use of the last pointer and display it. That is last pointer info, just display. What is last pointer info? That is 40, and 40 has been displayed successfully. And after displaying the last element, what we do, we will stop here. We will stop here. But while looking into the loop, we can iterate it like this. While PTR pointer next is not equal, less than or equal to last node, or till we go for the last node. That also we can write. We can either use this procedure or other procedure. So this was the procedure for displaying or printing all the elements present in the linked list. Displaying all the elements present in the linked list. So in the next discussions, we will be looking into the implementation details of the linked list.